So there's the recording. All right, guys. So when we're talking about these quadratic functions, ax squared plus bx plus c, without the ax squared term, you would not have a quadratic. So this means that, guys, a cannot equal to 0. Everything else can be 0, but if a is 0, you no longer have a quadratic. So a cannot equal to 0. Now, additionally, as we move forward, I think I mentioned this to you guys before, but I'm going to mention it again. A is referred to as the leading coefficient, So when I talk about the leading coefficient, guys, I'm talking about the A value, the number in front of x squared. By the way, remember when we talked about the transformations? The A value has two purposes. It determines whether or not a graph is stretched or it's shrinking vertically, as well as whether the graph is going to reflect over the x-axis, okay? So the leading coefficient is important to know, as well as C, guys, C, and notice I'm not putting them in the right order alphabetically because I want to emphasize the more important values that you need to pay careful attention to. C is referred to as the constant. By the way, the constant, eventually, we call it the y-intercept if the equation is given to us in the general form. And we'll talk about these forms in a little bit. And then, of course, the B, if you guys are curious, okay, that's the coefficient of the linear term, coefficient of linear term. See, this is why I don't emphasize this, okay, guys? I rarely talk about the B like that, okay? What's important is A and the C value, okay? Now, in order to talk about these quadratics, guys, there's two forms we look at. By the way, this is primarily about graphing the quadratics. We're graphing quadratics, okay? So we got the general form, which is that f of x equals to ax squared plus bx plus c, okay? We're going to look at that one first. And then we've also got the standard form, which I refer to sometimes as the vertex form, okay? Or vertex form. Now, for the vertex form, guys, we are going to address it later, but for now, I'm just going to give you what it looks like. A times, the leading coefficient is still A, x minus h squared plus k. That's the vertex form. And this should look familiar to you too, because this should take you back to the transformations, guys, okay? So we're talking about graphing the parabolas. When you're graphing a parabola, guys, either the parabola is going to open up or it is going to open down. Now, what determines whether or not a parabola opens up or down? It's that leading coefficient, that A value. Once again, guys, there goes that A value. We're talking about it. So if you look at your A value and it's greater than 0, yes, it's positive, so it's going to open up. Now, if your A value, though, is less than 0, which means it's a negative, the graph will open downwards. The most important point on the graph of a quadratic, by the way, guys, the quadratic function graphs, they're referred to as parabolas, okay? Parabolas. And so, for these guys, the most important point on the graph of a quadratic on a parabola, of course, is the vertex. The vertex is the turning point of the parabola. The vertex is the most important point on a parabola, and we refer to it as the turning point, and its coordinate is listed as h, k. Its coordinate is h, k. This is the most important point on the graph of a parabola. And let me go ahead and also throw this in here. If a parabola is opening up, guys, especially since we just finished talking about max and min values in chapter 2, if a parabola is opening up, then the lowest point on the graph is actually at the vertex. So we would say that the parabola has a minimum value at the vertex. However, if the parabola is opening downwards, the highest point on the graph is at the vertex, at the turning point. So it would say the graph has a max value at the vertex, all right? Now, next, these graphs are symmetrical, guys, okay? They have a line of symmetry or axis of symmetry. Now, the axis of symmetry or the line of symmetry goes straight through the middle of the graph, guys, okay? And it breaks up the graph into two identical halves. two identical parts. So in other words, the left side reflects the right side and the right side reflects the left side. And so the lines of symmetry or axis of symmetry, let me write this down for you guys too. Axis of symmetry, line of symmetry, same thing. Guys, this is the most important thing, okay? Pay attention to this because you will get questions about this. The line of symmetry or axis of symmetry is an equation because it is a vertical line. And so it's intersecting the graph at the vertex. The equation is going to be in the form of x equals to whatever the x value of the vertex is. So in this case, if the x value of the vertex is h, then the equation is x equals to h. Here's why I'm telling you to pay attention to this, guys. You must write the line of symmetry. Whenever they ask for axis of symmetry, line of symmetry, in this chapter or whatever chapter you're doing, it must be in the form of an equation. X equals to whatever the x value of the vertex is, okay? So guys, I will go ahead and now move on to how do we graph these? How do we generate the graph of these? By the way, guys, on the graphing calculators, to graph on the graphing calculators, you want to go ahead and go to the Y editing screen. To get to the Y editing screen, you hit the Y equal button at the top left side of your TI graphing calculators, okay? That's how you get into the graphing calculator screen. And then you just type the problem and hit graph and it will generate the graph for you, okay? So guys, let's talk about how we graph these parabolas. To graph these parabolas, number one, you need to determine the direction of opening. Which way is the graph opening? So remember, I just mentioned that if the graph, in order for the graph to open up, the value of A must be greater than 0, as in it must be positive, so it opens up. Now, if the value of A is less than 0 or it's negative, it's going to open down. That's basic information everybody should be able to come up with. Now, once you figure out the direction of opening, guys, here's another very easy component to figure out about these graphs. They're y-intercepts. Find the y-intercept. Now, I will talk about finding the x-intercept too, but right now I'm focused on graphing. So to graph, determine the direction of opening, find the y-intercept. How do we find the y-intercept, guys? You let x equal to 0, solve for y, which is the same thing as saying find f of 0. So think about it, guys. If the quadratic function is this, can you explain the graphing calculator? Yeah, I'll go over it again, okay? So if you have f of x equals to ax squared plus bx plus c, guys, and you substitute 0n for each x, what happens is that the ax squared term cancels out, the bx term cancels out, and what are you left with? Just c. So essentially, guys, when you have your equation in the general form, which reminds me, I forgot to mention that, this graphing is about the general form, guys. The general form is what we're looking at first, the general form. I said that earlier, but I forgot to write it down. We're looking at the general form. So guys, when you're finding f of 0, you're finding the y-intercept. Basically, it's the c value when it's in the general form, okay? So 0 comma c is your y-intercept. That's easy to find. Now, next part of this, guys, is to find the vertex coordinate. Vertex, that's step 3. Find the vertex, h comma k, guys. Now, this is the most important point on the graph of a parabola. By the way, when you're graphing on My Math Lab, they will ask you to plot the vertex coordinate and plot one of the intercepts. The ideal intercept you want to plot is the y-intercept. So you plot the vertex first, then plot the y-intercept, and your graph should generate for you, okay? So guys, here we are. We're finding the vertex. To find the vertex, we're going to use the formula x equals to the opposite of b over 2a. Now, this will give us the x value. So this will help us to find the x value of the vertex, to find h. Now, once you find the value of h, which is the same thing as x, guys, you're going to substitute x into f of x to find the y value, to find the k value. The y value and the k value are exactly the same thing. So what am I trying to tell you guys? Here's the bottom line, guys. You find the value of x by using the formula, negative b over 2a. That's how you find x. You take that value, plug it into the function to find the value of y. And I'll explain that to you in a little bit, okay? So guys, remember whenever you're graphing in my math lab, you need 2 solid points. This will give you 2 solid points and you should be able to generate a graph using this information right here. But let me go ahead and add some additional pieces to this, guys, okay? Because one of the critical parts of these graphs is the line of symmetry. Remember, the line of symmetry shares the same x value as the vertex. It's in the form of x equals to whatever the h value is or whatever the x value of the vertex is. So to find it, you are simply going to use the formula negative b over 2a to find the x value of the line of symmetry, guys. So same thing, you got to find the line of symmetry. Find the line of symmetry. They're always going to ask you to find the axis or the line of symmetry whenever you're doing these problems. All right, so guys, hopefully this is sufficient. By the way, just on a side note, if they ask you to find the x-intercepts, find the zeros, or perhaps the x-intercepts, or perhaps they could ask you to find the roots. So all you do, guys, is this. Set the quadratic equal to 0 and solve. Set the quadratic equal to 0 and solve. Or take f of x, set it equal to 0 and solve. That's how you find your x-intercepts. By the way, not all these graphs will have an x-intercept. As we mentioned last time, we talked about the quadratics in chapter 1. Okay? So guys, here comes the examples. Example 1. F of x is equal to x squared plus 2x, okay, plus 3. Now, this is a quadratic function. They're asking you to graph it. So your first step is to determine which direction is this graph going to open. X squared is positive, so the graph is going to open up. It opens up, okay? And then they're going to ask you for the y-intercept. And remember, to find the y-intercept, you plug in 0 into the equation for every single x. So basically, everything cancels out but the 3. So the y-intercept would be 0, 3. Now, if you need to go ahead and find the vertex, okay, this is where the real work goes, okay? So for the vertex, guys, we're going to use the formula x equals to the opposite of b over 2a to find the corner of the vertex. This will help us to find the x value, and then we plug it back into the function to find the corresponding y value. Now, in this particular problem, guys, a is the number in front of x squared, so that's 1. B is the number in front of x, that's 2. C is the constant term, that's 3. So we're going to go to the formula and substitute everything in. The opposite of b would be negative 2 over 2 times a. So we simplify this, we get negative 1. Now, once you get that x value, you plug it back into the function for every single x. Work it out to find the corresponding y value, everybody. So you get 1 minus 2 plus 3. So this will turn out to be positive 2. Okay. Guys, if you have a question, please drop it in the chat, okay? 1, 2 is your vertex. And there we go. Now, we need some additional components, guys, for this. So next, we're going to find the equation. Notice I'm saying equation of the axis of symmetry. Remember, the axis of symmetry is a line that goes straight through the middle of the graph, and it is in the form of an equation. So the line of symmetry or axis of symmetry for this one, guys, since it shares the same x value with the vertex, will be x equals to 1. Now, guys, listen, I'm ready to go ahead and graph this. So I'm going to go to the xy plane, and I'm going to sketch the graph of this quadratic function. Now, as I do this, pay attention. I'm going to go back to the calculator in a minute and elaborate on graphing with using the graphing calculator. Okay, how'd you get the 1 for the symmetry? Okay, remember, it shares the same x value with the vertex, or you could just use the formula x equals the opposite of b over 2a. So the same way you find the x value of the vertex is the same way you find the line of symmetry. All right. Hold on a second. Is 1 positive? Hold on a second, man. Let me see. Did I leave out my negative? Opposite of B over 2 times A. Ooh, good question. Good point. John, you're right. It is a negative. So let's go back and scratch that. You know what? I would have figured it out because eventually, guys, that wouldn't have made any sense, okay? When I start graphing it, it wouldn't make any sense whatsoever. So let me go ahead and trace my steps back a little bit because I think Moria is pointing out, oh, you made a mistake there, okay? So the opposite of B would be -2 over 2 times A. So that gives you a -1. Now, when you plug a -1 in, guys, okay, that might change. Wait a minute. Let me see here. Did I do it with a -1, guys? And okay. You know what? I forgot to write down the negative. That's what happened. The +2 is fine. It's just that I forgot to write down the negative. Okay. So I didn't do that bad. All right, guys. So let's go back a little bit because I just checked my work there. All right. So let's do this graph, people. Let's see what this graph looks like. So the vertex is at -1, +2. That's located right here, guys. Remember, this is the most important point on the graph of a parabola. So that's the first point you need to graph, guys, just like on my math lab. First point you must graph is the vertex. Your y-intercept is right there, okay? Now, here comes where the line of symmetry comes in. The line of symmetry goes straight through the middle of the graph, guys, and intersects the graph at the vertex. Now, you should notice this point, the y-intercept, is on the right side of the line of symmetry, okay? So now we're going to use the line of symmetry to help us reflect this point across the line of symmetry. So we're going to reflect the y-intercept across the line of symmetry. Now, the y-intercept, guys, is 1 unit away from the line of symmetry on the right. So we're going to count 1 unit away from the line of symmetry on the left and reflect it, okay? How did I get the second point? The second point is the y-intercept, all right? So guys, now we have 3 solid points on the graph of this function. We can go ahead and graph it, people. So let me go ahead and sketch the graph out for you. So this is what the graph looks like. Oof, that was too wide. That's too wide, guys. That needed to be a bit thinner than that. It needs to be, you know, just a regular size parabola. But you guys get the point, okay? That was a little too wide. All right, so guys, we have our graph. Now, additionally, okay, you need to find some additional components on this, okay? So one of the questions they will ask you, does this graph have a max or min value? Because the graph is opening up, okay, if the A value is greater than 0, guys, then it is going to have a minimum value. Now, the question is going to be, what is the minimum value? The minimum value is the y value at the vertex. In this case, the y value at the vertex is 2. So you have a min at y, you could put y equals to 2 or at 2, okay? Y equals to 2, that's the min value. Now, let me just go ahead and throw 2 more components on here, guys. They will ask you to find the domain of this graph. Remember, this is a polynomial function, guys. The polynomials, there's no restrictions on the domain. So the domain of this one will go from -infinity to +infinity. By the way, the domain for all of these quadratic functions, -infinity to +infinity. What you need to worry about is basically the range. So the range would be the lowest y value on the graph, which is at the vertex at 2, up to the largest possible y value on the graph, which is +infinity. So guys, there's your range and there's your domain. Any questions on this, guys? No? All right. So that was the first example. Now, for those of you who are concerned about the calculator, I think someone asked me the question. I forgot. So when you're graphing on the graphing calculator, the TI-80 series, 84, 83, it really doesn't matter, okay? You hit your Y equal button, okay? Hit your Y equal button. And then once you hit your Y equal button, you will see where it says Y sub 1. And then you just go in there and type in your equation. How do you type in your equation? You hit X, okay? X is the X/T and so forth and so on. And then you want to hit your x squared button, guys. Hit your x squared button so you could square it, and then keep typing the rest of the equation. Use the x comma t comma theta button. You should see it on the calculator screen, all right? The range and domain. Yeah, I can explain that, absolutely, okay? So I don't remember who asked me this question about the domain and the range, but hopefully I've answered your question. Let me know in the chat if I've answered your question, if you want me to elaborate a little bit more on the graphing calculator. Unfortunately, I did not download the calculator emulator on here. I'm gonna try and remember for next time to go ahead and download it. Which reminds me, guys, next time we are meeting at the college, actually this would be perfect because I can go ahead and use the emulator that's already downloaded on the desktop in the classroom and show you guys how to use the graphing calculator there, okay? So next time we are meeting in the classroom, guys, next Thursday, the 22nd, we're meeting in the classroom. So here's the second example. So someone had a question about the range, okay? Can you help me out with the range? And so I will go ahead and talk about the range in a little bit, okay? Negative x squared minus 2x plus 2 is the next one, guys. So let's go ahead and look, everybody. So on this one right here, the graph is going to open down. It will open down. How do we know it opens down? The negative leading coefficient tells us it's opening down. X squared is negative, okay? The leading coefficient is negative. The y-intercept, guys, the y-intercept is 0, comma, positive 2. Why? Because when you substitute 0 in for every x, you're left with positive 2. In other words, you're finding f of 0. All right, so now, guys, it's time to find the vertex, which is the most important point on the graph of the parabola. Remember, for the vertex, you got to do the opposite of the b value. By the way, this is your b value right there, okay? So the opposite of it would be a positive 2 over 2 times the a value. What's the a value? The negative leading coefficient, so negative 1. And then you simplify this, you get a negative 1, guys. Yeah, another negative 1. So negative 1 comma, now you got to find the y value. How do you find the y value? You take that negative 1x value, go back into the function, and substitute the negative 1n for every single x, and work it out, everybody. So negative 1 squared is 1, so that leaves you with a negative 1 plus 2 plus 2, so that's going to leave you with 3, guys. So there's the corner of the vertex. Any questions? All right, guys, for the line of symmetry, I'm writing it on the sign here. The equation is going to be in the form of x equals to whatever the x value of the vertex is, in this case, negative 1. So we use the line of symmetry to help us plot a third point on the graph, which I forgot to mention on the steps. All right, guys, so here we go. I am going to go to the XY plane. I'm going to try to do a better job with graphing the parabola this time, okay? Try not to make it look so wonky. All right, guys. So first, let's plot the vertex, negative 1, comma 3, which is located right here. Oh, let me use a different color. Right there, everybody. The y-intercept is 0, comma 2, which is right here. Okay, that's your y-intercept. That's 1 point. That's your vertex. That's 2 points. Now, is it a negative? What is it? Is what a negative, man? Let me see. Let me read your question. Is it a negative 1 or a positive 1? Okay. When you do the x value of the vertex, it's the opposite of the negative 2, which becomes a positive 2 divided by 2 times the leading coefficient, and the leading coefficient does simplify to negative 1. Now, when you plug the negative 1 into the original function for every single x, you end up with a negative and then negative 1 squared minus 2 times negative 1. So what you need to be careful is that negative in front of the negative 1, you can't just multiply them together and get a positive. No. You got to square the negative 1 that's inside the parentheses and keep the negative that's outside of the parentheses. So that simplifies to negative 1. And then, of course, negative 2 times negative 1 is positive 2. And then you add it all up, so you get 3, okay? So yeah, I did double check this one, man, just to make sure. I think what happened with the last problem is that I forgot to write down my negative sign, okay? It's not that I made an error on the problem. I just forgot to write down my negative sign. All right, guys. So here we are. We have our vertex coordinate right there. We have our y-intercepts. So I'm going to go ahead and draw the line of symmetry through the middle of the graph. You will notice the y-intercept is on the right side of the line of symmetry, one step, 1 unit away from the line of symmetry on the right. So you're going to count 1 unit away on the left side of the line of symmetry and plot its reflection, okay? So the y-intercept is located at 0, 2. So its reflection is located at -2, 2. All right? And guys, remember these graphs are even function graphs. So notice this, guys, for 2 values we have, for 2 x values, we have the exact same y values. That's the definition of symmetry, guys. Balance. Symmetry has to do with balance. What you see on the left is what you see on the right, and so forth and so on. So guys, here's our beautiful graph, okay? I told you I was going to do a better job with this one. Perfect. That's beautiful, okay? So now, everybody, here's some additional components about this graph. First, does it have a max or min value? Does it have a max or min value? That's the first question. Because the graph is opening downwards, the leading coefficient is negative, guys. The highest point occurs at the vertex. So this one is going to have a max value. What is the max value? The y value at the vertex, in this case, 3. Okay, so now I'm not going to talk about, thank you, man. I'm not going to talk about the domain because all these functions have the same domain. So what we need to talk about is the range. How do we find the range? Remember, the range is the vertical part of the graph, the lowest y value on the graph up to the largest possible y value on the graph. Now for this graph, guys, it starts at +3, and then it decreases on the left, it decreases on the right down to -infinity. So the range goes from -infinity up to the highest point on the graph, which is at the vertex. Okay, I think I got bitten by a mosquito here. Okay, so guys, the vertex right here is at +3. All right, so there's your range. Somebody had a question about finding the range. Hopefully that makes sense to you. The lowest y value on the graph up to the largest y value on the graph. Okay, let me know if you want me to clarify that some more. Anybody? Okay, guys, so that was our second example. Hopefully you're feeling comfortable with this. All right. And so I am going to transition to the standard form, and we'll do some addition. Why does the 3 have a bracket? Because the 3 is part of the graph. Remember, that's the vertex. Okay, it's at -1, 3. So the 3 is part of the graph. That's why you want to include it. All right. So now, guys, I'm transitioning over to the vertex form. Now, everybody loves the vertex form. Well, I'm calling it the vertex form. I meant the standard form, guys. I love calling it the vertex form because once it's in that form, guys, you can essentially eyeball the problem and figure out the coordinate of the vertex. You don't have to do any work to find the coordinate of the vertex. That's why I like calling it the vertex form. All right, guys, so once it's in this form, like I said, you would just eyeball the equation. Oh, this thing is not writing for me, okay? Hold on a second. You're going to just eyeball the equation, guys, and figure out the vertex. And the vertex is h, k. That's it. I know. What are you talking about, okay? So let me give you a quick example. Let's say you have f of x is equal to negative x minus 2 squared plus 1, okay? Now, here's the thing you have to remember, guys. When you're finding the vertex, if it's in standard form, you got to remember to take the opposite of what's inside the parentheses. And this goes back to the transformations in chapter 2, where if the transformation was inside the function, you had to do it in the opposite direction. So for this one right here, guys, listen. If I give you this function, I ask you for the vertex, you do the opposite of what's inside the parentheses because you want what's inside the parentheses to become 0, so you do its opposite. And then comma, the value on the outside. Remember, the number on the outside moves the function up and down, and the number inside moves the function left or right, guys. So that's your vertex. That's why I call it the vertex form. I just eyeball this and figure out the coordinate of the vertex. Easy, okay? So just like before, guys, if you're going to graph, you need the vertex. We have the vertex, okay? What else do we need? We need to determine the direction of opening. Which way is this going to open? Well, the leading coefficient is right there. So this one is going to open down. And then of course, they're going to ask us for the y-intercept. That's the one you have to do work for. For the y-intercept, guys, just like before, you want to substitute 0n for x and then work it out to find the corresponding y value. You see all the work I'm going to have to do for the y-intercept this time? Because it's in a different form, guys. So we get a negative 2 squared plus 1, which leaves us with a negative 4 plus 1. So this is going to give us a negative 3 for the y-intercept, 0, negative 3. All right, and then of course they will ask you, what is the axis of symmetry or the line of symmetry? The equation for this one is going to be x equals to the x value of the vertex, which in this case is going to be 2. So x equals to 2 is the axis of symmetry. Anybody want me to graph this one? Do you guys want me to graph it so we can get additional practice? Yes? Okay, all right, so let's graph it. You guys have to remember all of this because I'm erasing this, okay? All right, so the vertex is 2, 1. The y-intercept is 0, negative 3. And then, guys, what did we say? It opens down. And the axis of symmetry, the line of symmetry, axis of symmetry, is going to be x equals to positive 2. So let's graph this one. Okay, guys, so we're going to go to the xy plane once again. And this time the vertex is located at 2, 1. So let's go ahead and give it a try. 2, 1 is located right here. All right, so now we're going to plot the y-intercept, 0, negative 3. All right, here's the line of symmetry, straight through the middle. Now this time, guys, the y-intercept is located 1, 2 units away from the line of symmetry. So you got to count 1, 2 units to the right side of the line of symmetry and plot its reflection. So this is what the graph is going to look like. And just like that, I'm done with my graph. Okay, so let's talk about whether or not this one has a max or min, guys. What do you think, max or min? Yeah, this one has a max. And what's the maximum value, guys? Y equals to positive 1. Okay, so that's your max value. Now, you will be asked, what is the range? The range, guys, is the lowest y value on the graph up to the largest possible y value on the graph. So this one will go from negative infinity up to the largest y values at the vertex. And so that would be positive 1. And you want to close it off with a bracket. That's the range. Now, on this one right here, it looks like the graph has 2 x-intercepts, guys. So I'm going to try and find the x-intercepts for this one, okay? So how do we find the x-intercepts? Okay, I am going to, you know what? Let me leave this on here. Let me just erase some of it. Okay, I'm going to erase some of this, guys. All right, so how do we find the x-intercepts? How do we find the zeros? How do we find the roots, guys? So for this one, we're going to go to the function, which was f of x equals to a negative x minus 2 squared plus 1. Set it equal to 0. And then solve. Now, for this one right here, I'm going to take the negative x minus 2 squared and move it over. So I have 1 equals to x minus 2 squared. I just moved the x minus 2 over because I want it to be positive. Now, to solve this, guys, we're going to use the square root property and take the square root of both sides. Now, be careful. Remember, when you take the square root of both sides, you get a compound solution. So this is where we're at. And then you add 2 to both sides. Add 2 to both sides. Okay? So guys, this will simplify to x equals to 2 plus 1, which is 3, 2 minus 1, which is 1. So there's your x-intercepts. So essentially, the graph of this quadratic should intersect the x-axis at x equals to 1, as well as at x equals to positive 3. Now, again, when you're graphing on My Math Lab, guys, preferably use the y-intercept because the graphs will always have a y-intercept. However, not all these quadratics will have an x-intercept. Some of these graphs will not intersect the x-axis at all. Yeah. Okay, guys. So that was the third example. Do you guys want me to do one more, or are you good? Because I would like to get into some of the word problems. One more. Okay, friends. All right. You know what? I don't even have my book next to me here. I'm going to have to fudge my way through this problem. Okay, everybody. So here comes the next one. F of x equals to negative 2 times x plus 1 squared. And guys, remember, all of these graphs, you can generate them on the calculator. So next time when we're in class, I will show you how to do this on the calculator, okay? Now, this one is going to open down again. The vertex, guys, is the opposite of what's inside the parentheses, comma, what's on the outside. There's a positive 1 inside, so it's going to become a negative 1. And so we don't have anything on the outside. So the y value will be 0. The graph is not moving up. It's not moving down. Additionally, everybody, we need to determine the y-intercept. If we substitute 0 in for x, what do we get for y? We're going to end up with, let me see here, negative 2, guys. Negative 2. All right. And of course, we need the line of symmetry. And the line of symmetry shows the same x value with the vertex. So it's going to be x equals to negative 1. So we got all the components we need to be able to graph this. So we're going to go ahead and go to the xy plane and graph, everybody, okay? So on this one right here, the vertex, guys, I always plot the vertex first, guys, always. And it's become such an ingrained habit for me. I cannot see myself graphing parabolas any other way. I have to plot the vertex first. So here's my vertex at negative 1, 0. All right, my y-intercept is at 0, negative 2. Here's my line of symmetry straight through the middle. The y-intercept, guys, is 1 unit away on the right side of the line of symmetry. So I'm going to count 1 unit to the left side of the line of symmetry. And I reflect that y-intercept. So I'm good. I've got my graph. There it is. Ooh, I missed that point. Okay, guys, so there's my graph. And then, of course, the question might come up, does it have a max or min value? This one would have a max value. What's the max value? The max value is at y equals to 0. The y value of the vertex. All right. Additionally, they will ask you for the range. How did you get the y intercept for this one? You take 0, you plug it in for x. So you do f of 0 equals to negative 2 times 0 plus 1 squared. 0 plus 1 is 1. 1 squared is 1. So you get negative 2. Yeah. All right, guys. The range on this one, for the range, everybody, is the range negative infinity to 0? Absolutely, Jessica, you're right. It is. The range is from negative infinity up to 0. Absolutely. Very good. All right, guys. So I'm moving on to a word problem. Actually, it's going to be a couple of word problems. Hopefully, I remember the nature of these word problems. And guys, I'm going to tell you right now, both of these word problems will appear on the assignments as well as on the test for this chapter. And this chapter test is going to be online as well, okay? So guys, here we go. You pay attention, okay. So guys, I'm gonna try and summarize this problem because I don't have the problem in front of me. It's in the assignment. If you don't fully get it by the time we're done with this, once we go through the assignment, if you guys want me to, I can go ahead and take some additional questions, okay? Now, this is I like calling it the farmer ed question. A farmer would like to fence his plot of land that borders a river. So this is what the figure is going to look like. You will be given a figure, guys. So he's going to fence in a plot of land that borders a river. He's got 200 feet of fencing, okay? 200 feet of fencing to plot this plot of land, okay? I mean, to fence this plot of land. He's not going to obviously fence the part along the river. So he's going to use X amount here, X amount here. And so whatever's left over will be used for the length. So what's left over would be the total amount of fencing minus the two sides, guys. Now, on the test, guys, you will not get a figure. On the assignments, you will get a figure, but on the test, you will not get a figure, okay? So, guys, the question is, what is the length and the width that would maximize, you hear the key word in there, that would maximize the area. And then they also want you to find the max area. What is the length? What is the width that would maximize the area? And what is the max area? So guys, here it is. First, we know to find the area of a rectangle, we do length times width. So in the case of this problem, we would do area equals to 200 minus, let's write it in terms of a function, guys. So let me rewrite this. Okay, in terms of a function, it would be a of x, in terms of x, equals to 200 minus 2x times x. You want to distribute the x, so you get 200x minus 2x squared. I am going to rewrite this in descending order of powers, guys. So this function to calculate the area is going to be a negative 2x squared plus 200x. Now, here's why I say it's great to pay attention, guys. It pays to pay attention, okay? Here's the operative word in here, maximize. When you think about maximizing, max value, maximum, where do you go to find the max value, guys? Where do you go to find the max value? And in order to have a maximum, what kind of quadratic function do you have to have, okay? So you have to ask yourself those questions, okay? That's brainstorming the problem. So here we ended up with this function. What do you notice about the function? The leading coefficient is negative, which makes sense within the context of the problem because you want to maximize the area. So where do we go to find the maximum? We go to the vertex of the parabola. By the way, guys, I forgot to mention, this is a quadratic. The highest power in this problem is 2. You have an x squared function. It's a quadratic function. So yes, the highest point is going to occur at the vertex. So yes, you should be able to find the length and the width that should maximize the area and then be able to find the maximum area. All right, guys, so now, because I'm running out of space, I'm just gonna come in here and do this, guys. First, we need to figure out x. By the way, x represents the width, guys, okay? X is going to represent the width. Now, when you have an equation in the general form, how do you find the x value of the vertex? Remember, you need the vertex, guys. That's where you go to find the maximum values, okay? So how do you find the x value of the vertex? We use the opposite of b over 2a. The b value here is 200. So we do negative 200 over 2 times negative 2. You want to work this out. Basically, negative 200 divided by negative 4. And this is going to simplify to 50. So essentially, guys, the width is 50. Now, let's think about this. If the width is 50, guys, okay, and you have to find the length, the expression for the length is 200 minus 2x. That means that the width, the length is going to be what, guys? What is the length? If the width is 50 and the expression for the length is 200 minus 2x, what's the length? What's the length, everybody? Ooh, did I stump you guys? Are you guys not paying attention? Is it 4 fronts? Come on, I'm disappointed, man. Okay, listen. This is your width right here. It's 50. The expression to find the length is 200 minus 2x. 200 minus 2 times the value of x. We just found x. X is 50. So 200 minus 2 times 50 will give you, right, 100, guys. So we just found the length. We found the width. Now let's talk about the maximum area. How do we calculate area again? We do length times width. So the max area is going to be the length, which is 100, multiplied by the width, which is 50, okay? So it's going to be 5,000 square feet. That's the maximum area of this plot of land, guys. This question is on the test, everybody. It's on the test. And you will see it in the assignments, okay? Yes, Moria. Okay. So that's one of the word problems, guys, you'll encounter. Okay, the next one is not going to be on the test, but you will see it in your assignment, okay? And I like to call this the well, no, wait a minute. You will see it to some extent, but not this long, okay? I like to call this the hunky beef problem, okay? And the reason why I call it the hunky beef problem, you know, when you name your word problems, guys, people have a tendency to memorize them a little bit better, okay? So hunky beef, guys, is a sandwich store. And I'm summarizing because I don't have the problem in front of me, okay? What they do is they sell sandwiches at 55 cents. Ooh, it's not, oh, there we go. Okay, 55 cents. Okay, this is not writing really well. Okay, 55 cents per sandwich, okay? And then they have a total overhead cost of $525 to buy supplies for overhead, okay? So guys, the question is this. First, part A, write a cost function. Write the cost function in terms of X. And X will represent the number of sandwiches made and sold, okay? So the cost function is going to be C of X equals to the overhead cost, $525, plus the cost for making each roast beef sandwich at 55 cents per sandwich, okay? You can write it like this, or you could do C of X is equal to 0.55X plus 525. Now, I know some of your sticklers, you might want me to put that 0 there, so I'm putting that 0 there, okay? So that's the cost function. Next, guys, we are going to write a profit function. Now, in order to write the profit function in the problem, within the problem, they're going to give us the revenue function, okay? The revenue function, guys, the revenue function is this. By the way, revenue is how much money is collected from the restaurant, from the business, okay? This is the revenue function right here, guys. Negative 0.001x squared plus 3x is the revenue function. So now they want us to go ahead and write a profit function. So how do you calculate the profit from a business? You take the total revenue you collected and you subtract the overhead costs. So the revenue function is negative 0.001x squared plus 3x. And then you're going to subtract the cost function. What was the cost function? 0.55x and then plus 525. So this is going to help you create your profit function. So guys, the profit function, okay, distribute that negative over the parentheses, is going to be negative 0.001x squared plus, now be careful with this, 3x minus 0.55x is going to be 2.45x, and then minus 525. That's your profit function, guys. We're not done yet. This was only part B, and then there's a part C. Here comes part C, guys. Part C is this, guys. How many roast beef sandwiches must be made and sold in order to maximize the profit? Maximize the profit. You hear that critical term in there, guys? The operative word is maximize. And just like with the previous problem, where do you go to find the maximum? What kind of quadratic function do you have that would lead to a maximum value? You have to have a quadratic with a negative leading coefficient so that the graph of the quadratic opens down, and you would have to go to the vertex to find the max value, guys, okay? So guys, how many sandwiches must be made and sold in order to maximize profit? Well, you got your quadratic function right here. The profit function is a quadratic function, so we're going to use that to help us figure out the number of roast beef sandwiches that must be made and sold to maximize the profit. So guys, I want you to grab your calculators. Hopefully you have one near you. Oh, I have one near me too. Okay, so we're going to do the opposite of the B value, the 2.45, divided by 2 times the value of A, negative 0.001. And I want you to type this into the calculator, guys, because I want to make sure you're getting the correct answer for this problem. We're doing part C. So on the test, you will get a profit function like this, and you will be asked to find some information about it, like how many sandwiches must be sold, made and sold in order to maximize the profit, and then what's the maximum profit. So you won't have to do parts A, B, you just have to do the last part of this problem right here. So guys, throw it on your calculator, see if you get the correct answer. And type it into the chat for me and let me know what you guys got. Okay, there we go. Very good, John. No, that's not John, that's Moria. Okay. Yes, it is 1225. Guys, you need to check and see if you're getting 1225. Okay, if you're not getting 1225, you need to ask a question as to how are we getting that 1225. Okay, now we're not done. The next part of this, of course, is what is the maximum profit? What's the max profit, guys? Okay, so for this one, to find the maximum profit, we take the 1225, we go and plug it back into the profit function. So we're going to go into the profit function and we're going to substitute the 1225 for every X and work it out, guys, to figure out the profit, the maximum profit. And by the way, because we're talking about money, you need to round it to 2 decimal places. And guys, try typing this one into your calculator as well. I got 0.00. No, Angie. How'd you get point? Is that for the X value, Angie? Did you get that for the X value?
That was for the, like, how many hot dogs? I think the last part. Yeah. The last one.
Okay, you got the same thing? Okay, so when you guys are typing that into your calculator, listen, do negative 2.45 and then divided by, open parentheses, 2 times negative 0.001, okay? That's how you type it into the calculator. Try it that way. All right, did anybody get the maximum profit yet? Ladies, make sure you try it on your calculator again to see if it works out, okay? So guys, the profit I'm getting is 975.63. Make sure you're rounding accordingly. This is money. Did you guys get that? Okay. So guys, listen, it's about 5 o'clock. I'm going to stop this video and then I will take your questions.